Hello and welcome to the final section of our course, putting the application together. In this section, we'll see how testable our code actually is by doing a few unit tests. We'll summarize what we've covered in this course and give some ideas how to apply that in our everyday work. Let's dive right into writing your first unit test. It's never too late to write the first unit test, and for us it's at the end of our course. In this video we'll see some changes to the project structure and then we'll create our first unit test. Let's look at the project structure. I have created two new projects, the Books.Core and the Books.Infrastructure. The Books.Core is where all our business logic is. In here we'll see the core types in Books.CS. We'll see iBooks source and actions like select, search, add, so on. This project does not depend on the other projects of the solution. Rather, they depend on it. Books.Infrastructure is where we keep all our concrete implementations, like books.json.source, which is a concrete implementation of the iBooks source. Finally, books.console depends on both the core and the infrastructure, and it's the higher level component we spoke of earlier. It puts together the parts of the logic that are pure and the parts that have side effects. A nice thing that comes from this project structure is that since infrastructure depends on core, core cannot reference infrastructure, because that would create circular dependency. In this way, should someone mistakenly want to instantiate the books.json source or any other concrete implementation inside of the books.core project, the tools, Visual Studio in our case, will stop them because that would create a circular dependency. Alright, now to the unit tests. Let's start with creating a new project to house our new unit tests. Right-click on Solution, Add, New Project. I've pre-selected the XUnit test project. Let's call that books.tests. Visual Studio scaffolds our project and one unit test file called unit test1. We'll rename that in just a second. Let's start with testing search by title. We need to include a reference to book.core in the books.tests. We'll say add a reference. We'll choose the books.core. Now our first unit test, let's rename that. I want to call our first unit test with this long name. When matching titles found, should return all books with matching titles. This is a naming scheme I try to keep when naming unit tests. The underscore is there to separate the main part of the test's name/description, when underscore should, and then in the parts I use Pascal case, like this, when some action underscore should some expectation. This is convenient for me because it gives me visual separation of the main parts of the name. Hence, our unit test is named when matching titles found, underscore should return all books with matching titles. For some more complex scenarios, it's useful to add a precondition, a given. In that case, it would become given when should, which is also known as given when then. This is really a personal and team preference, and please go ahead and use whatever makes the tests more understandable and conveys the idea in the most suitable way for your team, environment and preference. I also like to use the AAA, Arrange, Act, Assert, that gives similar separation inside the test body. Again, personal preference, team acceptance are key here. Alright, so we'll start by arranging to have a couple of books in a books collection. Condition, a given. Then we'll act. And finally, we'll assert. We'll assert against the collection of titles, so we need a expected titles variable. Let's create that. Alright, so now our unit test compiles, but I don't think it will pass because we are passing an empty collection of books. Let's see that fail. I'll be using the Test Explorer, which can be found from Tests, Windows, Test Explorer. Let's pin that. As you can see, XUnit gives the name of our test, prefixing it by the name of the class and the name of namespace. We might get rid of the namespace because that's really not something we need. We might not. So our unit test is called search by title tests dot when matching titles found should return all books. Let's run that. It actually passes, but that's alright because we actually expect titles to be an empty collection, and that's exactly what the found would return to. So let's say that we want to search inside an actual book collection. I've created these 3 books titled 1 match, 2 not, 3 match, and given that we are searching by the term match, we should see 1 and 3 match. So now if we run the unit test, we'll see it fail. Alright. And now we want to update our expected titles. And we don't need this equal sign here, of course. Now if we run this unit test, it should pass. There we go, it's passing. Alright, so for the rest of the unit tests, I have pre-written those to not lose time in here. The next one would check our business logic in the case when we want to ignore the casing of title. So our title is one capital M match, then third M match with capital T. So the expected titles would be same, 1 and 3. And then we also want to check when no books match, it should return the empty collection. So we change the search by title search criteria. We can go ahead and run all those tests. Alright, they pass. I'd like to mention that now we have tested all our assumptions and intent when creating the search by title. You know, that we should ignore case, we should return the empty collection when there's nothing found. So these tests are now a special case of a documentation. They document our assumptions and our intent by coding them in the tests. They live together with our code and validate our logic and change when our logic needs to change. So this special kind of documentation, the tests, is something I really like about having unit tests.